Hey, good people, this is section 2.3b, graph equations of lines in standard form. Your boy, Mr. Bergman, right here, coming to you. Here we go. Standard form, what does that look like? Standard form is usually like a number x and then plus or minus a number y equals a number. Standard form. Um, doesn't matter why they call it standard form right now. I'll tell you later in class if you like. But you can notice, like the four examples that I have here are all in standard form. X term, y term equals a number. X term, y term equals a number. X term, y term equals a number. So let me show you a short way. If you wanted to, some some algebra teachers insist that you solve for y, and you might feel more comfortable graphing things when you solve for y. But honestly, I think it's a lot easier to do it a different way. Let me show you what I think is the kind of the shortcut. We're going to do what's called a 0-0 table. And so what I've got here is I've got a table, and anytime I'm going to graph, we got to go equation table line. It is really the one of the best ways to do it. But this table is a little different. It's not going to be like a 0-1-2 table or like a, I don't know, 0-3-6 table. What I'm going to do is I'm going to first put in 0 for x. That's kind of standard. And then, so we put in 0 for x. You get 6 times 0, which this term drops away, and it's just negative 7y is equal to negative 42. Divide both sides by negative 7, you get your answer of 6. And here's where the tricky thing comes in. I'm not going to plug in another number for x. I'm going to plug in a number for y. And that number is also going to be 0. We know, I see what happens when x is equal to 0. Let's see what happens when y is equal to 0. I'm going to start over here in what you normally think of as the output. I would put 0, and then put it 0 in for y. 6x minus this term disappears, and we just 6x equals negative 42. And again, I divide both sides by 6, and I get another number, negative 7. Now, graphing these, it can be a little confusing because, like, do you go up or down or left or right first? Graphing zeros is actually sometimes harder than it. I know people get mixed up, but 0, 6, you go left or right 0, and you go up 6. Then here for this, you go left or right negative 7, and you go up or down 0. So you got a point here, you got an x-intercept and a y-intercept, and you graph these. Anytime you want to find both the x and the y-intercept, this table is a handy thing to use. I call it a 0-0 table. Now watch what happens. I'll give you like the short version of what it would look like, basically, if you were to solve this for y instead. This is the answer. I'm done. I produced a graph. The instructions were to graph. I've produced a graph. But alternate method, if you wanted to solve for y, you would have to subtract 6x from both sides and then divide all the terms on both sides by negative 7. You could do it. It would look like this, and this turns into just something that's kind of tricky to graph sometimes because of the fraction. I think 0-0 tables are a lot easier. But if you wanted to, you could solve for y and do it that way. Graph this. Let's do another 0-0 table. Plug 0 for x, and then 2 times 0 is that, minus y is equal to 4. And then you get negative 4 is equal to 4. Divide both sides by negative 1, and this turns into negative 4. Yeah. Again, here's the sneaky part. Don't plug in a number for x. Plug in a number for y over here. If 0 is y, then you get 2x minus something that drops out. You get 2x equals 4. Divide both sides by 2. And you get 2. So now I can plot 0, negative 4. That's going to be my y-intercept. My x-intercept is going to be 2, right here. Draw a line through them. And again, if you wanted to, you could solve for y. You would have to subtract 2x from both sides, and then divide both sides by negative 1. This actually isn't that complicated of an answer of an equation to graph. You can see it's right here. However, I think just solving for y is not as easy as just a 0-0 table. So let's do that instead. Okay, plug in 0 for x. The first term drops out. You get negative 3y is equal to negative 12. Dividing both sides by negative 3, you get 4. Plug in 0 for y, and this term drops out. You get 6x equals negative 12. Dividing both sides by 6, you get negative 2. Plot the points, connect the dots. Done. If I wanted to, I could solve for y and get kind of this straightforward equation, But I think it's just easier to put 0, 0 in. Solving for y would involve subtracting 6x from both sides and then dividing all the terms on both sides by -3, which is not impossible. I just think it's easier. Okay, x plus 2y equals 8. 0 in for x. Why don't you figure out what y is in this situation? When you divide both sides by 2, what do you get? But then, 0 for y. Here, this term drops out and it's just x equals 8. So there it is. Graph it. 8 comma 0 is over here, and the red dot number is over here. If you wanted to, yeah, you could solve for y. Subtract both x, so that's the answer. But if you wanted to, alternatively, another method is you could just solve for y, subtracting the x from both sides and dividing both sides by 2. And this is what you get. All right, y'all, that's it. Thanks for paying attention. Oh, wait a minute. Audio check. I wanted to let you know where I got married. Actually, this is long before I ever knew what Chestnut Hill was, or long before I had my first home. I found the Morris Arboretum, and my wife and I looked at it and we were like, "Hey, let's get married here," and we did. I'll tell you all about it more in class if you like. Take care, and I'll see you in class.